1A, what's up? So we've learned to solve systems by graphing, substitution, and elimination. Today, we are going to now apply what we have learned to some word problems. I know, you're super excited, aren't you? Don't worry, we're going to take this slow. We'll do a few today, a few the next day. You'll practice as you go. We'll do a Google Hangout. If there's questions, if there's problems, we'll take it slow, so don't worry. Before you left, you got this packet of your worksheets. Hopefully you have that. If you need to pause the video and go get it, you can do that stuff. If you flip back in the packet to where it says 13.4 notes and looks like this. So get that stuff, paper, pencil, calculator if you have it. If you don't have a calculator, you can pull up Desmos and use that. Desmos Scientific Calculator, just Google search it, pull it up. So get all that stuff together, come on back, we're gonna start going through the problems. All right, hopefully you have everything. Let's go ahead and do it. So first question says the following, and I know there's a lot of highlighting and stuff in there. We're going to take it a little bit at a time. So it says the school that Terry goes to is selling tickets to a musical performance. On the first day of ticket sales, the school sold 30 adult tickets and 12 student tickets for a total of $456. The school took in $696 on the second day by selling 42 adult tickets and 24 student tickets. Find the price of an adult ticket and the price of a student ticket. Whew, scary, right? Not really. So the first thing that I'm going to point your attention to is the very last sentence. Find the price of an adult ticket, find the price of a student ticket. That means that there are two unknowns. If there are two unknowns, we have to have two equations to solve them. That's what systems are all about. Finding two solutions. X value and a Y value. Normally, now we're talking about student tickets and adult tickets. So here's the first thing I like to do. I like to define my variables. In other words, I'm going to state two variables equal to my unknowns. That's what a variable is. Since we're talking about adult tickets and student tickets and their price, I'm going to use A and S. So at the top of my paper, my whiteboard, I'm going to define A as cost of an adult ticket. I'm going to define S as the cost of a student ticket. That is the very first thing that you need to do in order to start writing equations that you can solve. Identify what variables you're going to use. Now, after that, I'm going to go back through my problem and say, are there two situations that I can write an equation from? And the nice thing about this first example is it really lays out those two situations. It talks about the first day, it talks about the second day. So let's go back to the first day. It says on the first day of ticket sales, the school sold 30 adult tickets and 12 student tickets and got a total of $456. So right there is the equation that I'm going to use. So if I've sold 30 adult tickets, the amount of money I've brought in off of those adult ticket sales would be the cost of an adult ticket times the number of tickets I sold. So the first thing I'm going to put down is I'm going to put 30 times A. That gives me the amount of money that I brought in on adult tickets. I'm going to add to that what I brought in for student tickets. Since I sold 12 student tickets, 12 times S would give me the amount of money generated off of ticket sales. Adding those together gives me the total amount of money brought in, which in this case is $456. Now, I can't solve that. I've got two variables. I need another equation. So this is where I'm going to set up my second equation, and that comes from the second day. It says the school took in $696 on the second day. So that means when I put my ticket prices together, or the amount of money I brought in on each ticket sale, that's going to equal $696. We sold 42 adult tickets, which will be 42A, and we sold 24 student tickets. So the amount of money made on the adult tickets plus the amount of money made on the student tickets will give me the total amount of money made. I now have two equations using the A and the S, the two variables that I've defined. I now have a system that I can solve. Given that this guy is in standard form, in other words, it's not solved for a variable, it's A and S, I'm probably going to go ahead and go with elimination here. I have a feeling you guys prefer that method the most anyway. So when I look at this, I'm going to survey it and say, does it look like it'll be easier to get rid of the A's or the S's? Well, I'm immediately drawn to the S's. The reason I'm drawn to that is this is 12, this is 24. They're not opposites, but they could easily be made as such. So what I'm going to do is I'm going to take that top equation, I'm going to multiply that guy by -2. So when I do that, that top equation will become -60A minus 24S, and that will equal -2 times that is what? -912, I believe. Let's verify with our calculator just to make sure my mental math is up to snuff. -912. Now we did not change the bottom one because that guy is positive 24. So I have 42A plus 24S equals 696. Now before you dive in, I'm going to take a look and say, before I add these together, will something cancel out? Do I have a variable that's opposite coefficients? And I do. I have a -24 and a 24. So when I add those together, I will get a variable to eliminate. So -60A plus 42A will give me -18A. My -24S and 24S will cancel out, and that's going to equal -912 plus 696 is giving me -216. At this point, one-step equation to solve. Divide both sides by -18. Divide by -18. I'm looking at A. This will cancel out. Equals -216 divided by -18 is 12. So now that I have one variable, I can take that, plug it back into one of the equations, solve for the other. So choose which one looks easiest. I'm going to go with that, and make sure you go back to the originals. Don't forget that. So I'm going to go to this first one. So I have 30A, which in this case will become 30. We now know A is 12, so that's 30 times 12 plus 12S equals 456. Sorry, I'm kind of squeezing it in there. My board is only so big. So 3 times 12, of course, is 360. Let's verify. So that's 360 plus 12S equals 456. At this point, that's a two-step equation. We can solve that pretty easily. I'm going to subtract 360 from both sides. Subtract 360. That's going to give me 12S equals 456 minus 360 is 96. Then I'm going to divide both sides by 12. And that's going to give me S equals, I do believe that would be 8. We can verify if you want. Divide it by 12. I do get 8. Don't forget that this is a word problem, so do provide an answer in a sentence or some labels. So they asked me what the price was of an adult ticket and a student ticket. So I will write, and I'm sorry I don't have a lot of room here, adult tickets are $12. Student tickets are $8. There you go. There's our solution. Simple, right? Example number 2. Two schools both use the same company to take buses and vans on a field trip. High School A rented and filled 4 vans and 6 buses with 272 students. High School B rented and filled 2 vans and 2 buses with 96 students. Every van had the same number of students in it as did the buses. Find the number of students in each van and in each bus. So again, the last sentence really tells me I'm dealing with a system. I have to find the number of students in each van, the number of students in each bus. That's 2 unknowns. I need 2 equations, a system to solve. So we'll start by defining our variables. I'm going to have number of students in the van, number of students in a bus. I'm going to use V and I'm going to use B. V for van, B for bus. So V equals number of students in vans, and B will equal number of students in a bus. In a bus, on a bus. Okay, so again, I need 2 equations. The nice thing about this guy, it talks about high school A and it talks about high school B. Those are my 2 scenarios. So we'll start with high school A. High school A rented 4 vans and 6 buses and had 272 students. So 4 vans, the number of students total would be 4 times the number of students on a van. We're going to add to that the number of students that were on a bus. Since they filled 6 buses, I will write 6 times B to get the number of students in a bus or on all those buses. And that's going to equal the grand total number of students, which we know was 272. Again, 2 variables, can't solve that, need another equation. So we go to high school B. They rented 2 vans, so that's 2V for the total number of students on a van, plus 2 buses, and they had a total of 96 students. I now have 2 equations with the same 2 variables, and I now can solve it. Going to use elimination again, just because that makes the most sense here. So we can go after V or we can go after B, whichever one you choose. I don't think either one's that much more difficult. V might be slightly easier. I can make the V have opposite coefficients if I multiply this bottom one by -2. So the top one, I'm not going to change. The top one's going to stay as 4V plus 6B equals 272. The bottom one now becomes -4V minus 4B, and -2 times 96 is -192, I believe. We can double check my mental math if you'd like. So at this point, I'm now going to look at the problem and say, if I add it together, will something eliminate? And yeah, the V's will eliminate. So I'm going to go ahead and add these 2 guys together. When I add them together, I'm going to wind up with the V's canceling out. 6B plus -4B is -2B. And that's going to equal 272 plus -192 is going to give me 80. Oops. That is positive 2B. Did anybody catch that? Positive 2B. 6B minus 4B is positive 2B. I apologize for that. Then we're going to divide both sides by 2. And I'm going to wind up with B equals 40. Now that I have one variable, plug it back into one of the equations and solve. I have a feeling most of us would probably go for this guy, little simpler. So that one is now 2V plus 2. Since I now know that B is 40, I can put the 40 in for B, equal that 96. That gets real easy real quick. 2V plus 80 equals 96. Subtract 80 from both sides. 2V equals 16. Your 80s cancel out and divide by 2. V equals 8. So that tells us that there are 40 students on each bus, 8 students on each van. I don't have a whole lot of room, but that's what I would write for an answer. I assume we can handle that. Example number 3. And it's a lot like the first two. If you feel good about the first two and you want to pause the video and try number 3 on your own and then come back and see if you got it, you can do that. If you feel you need to just follow this, let the video play, keep going. Earl and Pete are selling apples for a fundraiser. Customers can buy small boxes of apples and large boxes of apples. Earl sold 5 small boxes and 10 large boxes for a total of $112.50. Pete sold 8 small boxes and 8 large boxes for a total of $108. Find the cost of a small box of apples, then find the cost of a large box of apples. So again, 2 unknowns. Number of small boxes, cost of the small box of apples, cost of a large box. So S and L, small and large. So S is cost of small box, and we'll have L equal cost of large box. So, 2 scenarios. We've got Earl and Pete. Those are our 2 scenarios. We'll start with Earl. Earl sold 5 small boxes. So 5 times the cost of the small boxes. And he sold 10 large boxes. So 10L equals the total amount of money he made was $112.50. Then we'll go to Pete. Pete sold 8 small boxes and 8 large boxes. So 8S plus 8L equals his grand total, which was $108. So now I have 2 variable system, S's and L's. We can solve this with elimination. Now, the only difference with this guy is we're going to have to multiply both of them by something. So I have a feeling, I would imagine a lot of people would gravitate towards the L's. Either one's fairly simple. The L's, since you're dealing with 10 and 8, you can go to 80, you can go to 40, you can go to 40 with the 5 and the 8. It doesn't matter. Remember, one has to be positive, one has to be negative. I'm going to choose to go after the L's, and I'm going to go to 40. So I'm going to multiply the top one by 4, and I'm going to multiply the bottom one by -5. Remember, one has to be positive, one has to be negative. So, got my calculator handy. 4 times that top one, 4 times 5S is 20S, plus 40L is going to equal 4 times 112.50, and that is $450. When I do the bottom one, that one is -5. Don't forget the negative. -5 times 8 is going to give you -40S. -5 times 8 is also -40 for your L. And that's going to equal -5 times 108 is -540. We can verify with our calculator if you don't trust my mental math. So now I can add these together. The L's will indeed eliminate. So 20S plus -40S is -20S. Your 40L and your -40L will cancel out, and that is going to equal 450 plus -540 is going to give you -90. And we can verify that if you do not trust me. So at this point, I'm going to solve. I'm going to divide both sides by -20. It's going to cancel out, and you'll be left with S equals -90 over -20 would be 4.5. -90 divided by -20 is positive 4.5, which I'm going to write as 4.50 because I'm keeping in mind that S is the cost of a small box. So we need 2 decimal places in that answer. Then to find L, I will take S and plug it into one of those equations. Either one, I don't know if either one's easier than the other. I'm going to go to this guy just because they're both 8. So this becomes 8S. Now it becomes 8 times 450 plus 8L. It's going to equal 108. So 8 times 450 would be 36. 36 plus 8L equals 108. Now it's a 2-step problem. I'm going to subtract 36 from both sides. Subtract 36. This is going to cancel out. 8L is going to equal, I believe that would be 72. Then I'm going to divide both sides by 8. And I'm looking at L equaling 9. Again, since it is a cost, I'm going to write it that way. So large is $9, small is $4.50. If I had more room, I would write that out. Cost of a small box is $4.50. Cost of a large box is $9. Guys, example number 4, last one for today. This one is semi-tricky for students. It's going to involve a plane, and I put a little diagram up here so we can talk for a little bit. First off, when you're dealing with a plane in the air, winds can affect how fast a plane goes. Excuse me. For instance, if a plane is in the air, and I know you love my drawings, I'm such an artist. So this plane, of course, they're both traveling that way. They don't fly backwards. I hope we know that. So this plane is going this way. If there's a tailwind, that means there is a wind pushing the plane along. If there's a headwind, that means the plane is flying into the wind. Why does that matter? Well, let's say that a plane can do like 100 miles an hour. We're just going to pick a real easy speed. If I have a tailwind of 10 miles per hour, when that plane's up flying at 100 miles an hour and the wind's pushing it at 10 miles an hour, that means it's going 110 miles per hour. So basically what I did there was I took the wind and I added in what the plane was doing. So 100 plus 10, that gives you 110 miles an hour. Likewise, if this plane was doing 100 miles an hour and this tailwind was 10 miles per hour, that means when the plane's up there going 100 but the wind's pushing it back 10, that means he's only really going 90 miles per hour. We subtracted them. So a tailwind increases how fast and how far the plane's going. A headwind decreases. So we're going to have to do some addition and some subtraction here. The other thing that I want to point out before we get to the problem is when it comes to distance traveled. I don't know if you've ever seen this equation before, but distance equals r times t. You may have used that in science. That just means distance equals rate times time. For instance, you're in a car, you're going 60 miles an hour. If I do that for 3 hours, if I go 60 miles an hour for 3 hours, how far did I go? Well, I have a feeling most of you go, well, you went 180 miles. Yeah, because the distance you travel is your rate, which we know is a speed, miles per hour, slope, rate of change. Get it? So if I do 60 miles an hour and I do that for 3 hours, the total distance I've traveled is 180. Okay? And I didn't put my units in there. This is just some background knowledge to make sure we can handle the next problem. So here we go. Let's give it a whirl. And there's another example of this, I believe, number 8. So you're going to see another example of this down the road. Doesn't look like I erased that well. Okay, so here we go. A plane flies into the wind against the wind current for 4.5 hours for a distance of 1,440 miles. The return trip with a tailwind, with the wind current, takes only 4 hours because it's going faster. Find the average speed of the plane in still air and the speed of the wind current. So we got 2 things to find. We need to define 2 variables. So the first one, I'm going to say P equals speed of the plane. The other one is the wind. So W is going to equal speed of the wind. Okay, awesome. So what are my two scenarios? Well, we have a trip out and a trip back. So we've got one trip one direction, one trip the other direction. So it says it flies into the wind against the wind current for 4.5 hours. So what we're going to do is we're going to take that 4.5 hours, that's its time, and we're going to multiply it times the speed of the plane. That'll tell me how far that plane's trying to travel. Since it's fighting the wind, we have to take off or subtract from that what the wind has done to it. The wind also affected it for the 4.5 hours of the trip times W. It's still, once you do how far the plane tried to go and how much the wind pushed it back, grand total if it finishes the trip is 1,440 miles. On the return trip, now it's got the wind helping it, so it doesn't take it as long. So this time it's 4 times P, and we're going to add to that 4 times W. It only took 4 hours on the return trip because now the wind's helping it. So it's as far as the plane went and as far as the wind pushed the plane. That's why we've added them together. And we also get 1,440 miles. So now we have a system. We can now solve this. So I'm going to multiply and get rid of them. These guys are already opposites. So all I'm going to do is multiply this top guy by 4 and this bottom guy by 4.5. Now, the beautiful part here is if I grab my calculator and I take 4 times 4.5, I'm going to get 18. So that means this top one is 18P minus 18W. And this bottom one is also 18P, but plus 18W. All those 4 times 4.5s work out to be the same. The thing that changes is the resultant. Up here, I'm going to take 4 times 1440. I'm going to get 5,760. On the bottom one, I'm taking 4.5 times 1440. That's going to give me 6,480. I now can solve. If I add those together, 18P plus 18P is 36P. These will cancel out. And the 5,760 plus the 640 is going to give me 12,240. That's an easy finish. Divide by 36. P is going to equal 340. My plane's going 340 miles per hour. I'm a little bit out of room. I'm hoping you can finish from here. P, I would probably go for this one, put the 340 in, solve for the W. Maybe it'll squeeze it in. 4 times 340 plus 4W equals 1440. I'm sorry, guys. This board is only so big. So 4 times 340 is 1360 plus 4W equals 1440. Two-stepper, subtract 1360. 1440 minus 1360. I'm looking at 80. And of course, if I divide both sides by 4, W equals 20. So my sentence at the end, the plane's going 340. We're dealing with miles. We're dealing with hours. So it's 340 miles per hour. The wind's going 20 miles per hour. So hopefully that was okay. We'll do another one of those. This one's typically the trickiest one. So here's what I want you to do. I want you to go to your worksheet and I want you to try, you can do 1, 2, 3, and 5. Skip 4 for right now. You'll see an example of that on the next video. So I want you to try 1, 2, 3, and 5. Check your answers. We will do a Google Meet and go over those if we need to. Okay? Good luck. I know word problems are not your thing. We'll make sure we're good when all is said and done. All right? We'll see you guys.